Welcome to my 25th tutoring session in A-level chemistry. In this video, I will give a brief overview of atomic size, ionization energy, electronegativity, and electron affinity. I will strongly recommend this video to students who would like to have a better understanding of the basic concepts relating to periodic trends. In this tutoring session, I will give a brief explanation about atomic radius, ionization energy, electronegativity, and electron affinity. This will be followed by a quick summary of the factors affecting these atomic properties. I will explain the atomic radius with respect to beryllium and magnesium atom. I'll explain ionization energy concept with respect to lithium atom. I'll explain the electronegativity concept with respect to hydrogen chloride molecule. And I will explain the electron affinity concept with respect to fluorine atom. I'll begin my session with atomic radius. Atomic radius is the measure of size of an atom, specifically the distance from the nucleus to the outermost electron shell in a neutral atom. I have color coded the core and valence electrons. Core electrons are highlighted in red, while the valence electrons are highlighted in blue. The beryllium atom has 4 protons in its nucleus, 2 core electrons in the first shell, and 2 valence electrons in the outermost shell. Now the core electrons are very close to the nucleus and they will experience a very strong attractive force towards the positively charged protons, and therefore it will be very difficult to remove the core electrons. While the valence electrons, they experience a very weak attractive force towards the positively charged protons as they are far away from the nucleus, and it will be easy to remove the valence electrons as compared to the core electrons. Now magnesium atom has 12 protons in its nucleus, 2 core electrons in the first shell, 8 core electrons in the second shell, and 2 electrons in the outermost valence shell. The atomic radius of beryllium is 110 picometers, while the atomic radius of magnesium is 140 picometers. So when you compare and contrast the electron structures of beryllium and magnesium, you'll find that there are 2 shells in case of beryllium, while there are 3 shells or energy levels in case of magnesium. So as the number of energy levels or shells increase, the atomic radius also increases. Now, what are the factors affecting the atomic size or radius? Let me begin with the first factor, number of shells. As the number of shells increase, the distance between the nucleus and the outermost valence shell also increases. And with the increase in distance between the nucleus and the outermost shell, the electrostatic force of attraction between the positively charged protons and the outermost valence electrons decreases. So as the number of shells increase, the atomic radius increases due to the increase in distance between the nucleus and the outermost valence shell. Second factor is inter-electronic repulsion. Now as the number of shells increase, there will be increase in the number of electrons in their respective shells. When there is crowding of electrons, it leads to electron-electron repulsion, and there will be inter-electronic repulsion not only between electrons within the shell but also between the shells. And as a result of inter-electronic repulsion, the charge, the negatively charged electron, it spreads, the electron cloud expands, it occupies more space, and as a result, the atomic size increases. What is effective nuclear charge? Effective nuclear charge is the electrostatic force of attraction between the positively charged protons and the outermost valence electron. It can also be defined as the net positive charge experienced by the outermost valence electron in a multi-electron atom. So effective nuclear charge is high in case of beryllium, while it is low in case of magnesium. Why is that? Because of electron shielding. So what is shielding? Shielding is a phenomenon where the inner core electrons partially block or reduce the electrostatic force of attraction between the positively charged protons and the outermost valence electrons. So as the number of shells increase, shielding also increases. Now each shell acts as a shield, and when you compare and contrast beryllium with magnesium atom, you'll find that there is only one shell in case of beryllium with core electrons, while there are two shells in case of magnesium with core electrons. So in case of beryllium, two core electrons shield the nucleus from the outermost valence electron, while in case of magnesium, 10 core electrons shield the nucleus from the outermost valence electron. Now moving on to the next property, ionization energy. What is ionization energy? Is the amount of energy required to remove an electron from an atom or ion in gaseous state. And ionization energy is a measure of strength of attraction between the positively charged protons present in the nucleus and the negatively charged electrons. Let me explain the concept of ionization energy with respect to the lithium atom. Now, lithium undergoes ionization, and in the process, lithium atom loses its 1d valence electron from the outermost valence shell and forms a lithium ion. And 520 kilojoules per mole of energy is required to remove the valence electron in case of lithium atom. And therefore, ionization is an endothermic process indicated by a positive sign. That is plus 520 kilojoules. So positive sign is an indication that it is a endothermic process, or it is an energy demanding process. Why ionization is a endothermic or energy demanding process? It is because of the Coulombic force of attraction between the positively charged protons and the outermost valence electron. So in case of lithium, there are 3 positively charged protons in the nucleus that attracts the negatively charged valence electron. So in order to remove the valence electron in lithium atom, you need to overcome the Coulombic force of attraction. So in order to overcome this Coulombic force of attraction, you need to spend energy, and therefore ionization is a energy demanding process, or it is endothermic in nature. And ionization energy is measured in units of kilojoules per mole or electron volts. What are the factors affecting ionization energy? Let me begin with the atomic radius. As the number of shells increase, the distance between the nucleus and the outermost valence electron increases, and this leads to increase in the atomic radius. So atomic radius in case of beryllium is less as compared to that of magnesium. So atomic radius is inversely proportional to the ionization energy. So with the increase in the size, the distance between the nucleus and the outermost valence electron, it increases, and this reduces the attraction. And as a result of decrease in attraction, the outermost valence electrons in case of magnesium, they are loosely held and they can be easily removed. And less energy will be required to remove the valence electrons in case of magnesium as compared to that of beryllium. So in case of beryllium, you will find that the valence electrons in the outermost shell are very close to the nucleus because of its smaller size. The distance between the nucleus and the outermost shell is less in beryllium as compared to magnesium, and therefore the valence electrons, they are tightly held, they are not loosely held. So valence electrons are loosely held in case of magnesium, while in case of beryllium the valence electrons are tightly held, and therefore more energy has to be provided in order to remove the valence electrons in case of beryllium. And same applies even in case of lithium, because even lithium has two shells similar to that of beryllium. So only difference is that lithium has one valence electron while beryllium has two valence electrons. So as the size atomic radius increases, ionization energy decreases. Second factor is electron shielding. As the number of shells increase, shielding also increases. So more the number of shells, more will be the shielding. And as a result of this, the distance between the nucleus and the outermost valence shell will be more, and the outermost valence electrons will experience a least attractive force because each shell will be acting as a shield, and will reduce the electrostatic force of attraction between the nuclear protons and the outermost valence electron, as in case of magnesium and beryllium. So in case of magnesium, shielding is more. In case of beryllium, shielding is less. So in case of magnesium, you find two shells with core electrons shielding the nuclear protons and the outermost valence electron, while in case of beryllium, you got only one shell with two core electrons shielding the nucleus from the outermost valence electrons. So as the shielding increases, ionization energy decreases. So more the shielding, lesser the attraction, and easier it will be to remove the valence electrons. So it will be, because of more shielding in magnesium, it will be easy to remove the valence electrons as compared to that of beryllium. So beryllium, less shielding and difficult to remove the valence electrons. Next factor is nuclear charge. So more the number of nuclear protons, more will be the electrostatic force of attraction towards the valence electrons. So nuclear charge will be directly proportional to the ionization energy. So more the nuclear protons, more will be the attraction, and more will be the energy required to overcome this electrostatic force between the positively charged protons and the outermost valence electrons. And next factor is electronic configuration. Now what is the driving force for lithium to lose its outermost valence electron? Or why lithium lose its outermost valence electron? Because it has to attain the stable electronic configuration. So lithium loses its only valence electron to attain the stable electronic configuration of helium, which is the nearest noble gas in the periodic table. And last factor is the penetration effect. Now electrons in the 1s orbital are very close to the nucleus as compared to the electrons in the 2s and 2p orbital. And therefore the electrons in the 1s orbital will experience a stronger attractive force towards the nucleus. So penetration effect is more in case of 1s orbital as compared to that of 2s and 2p orbital, because they are in higher energy level. And 2p orbital, they are far away from the nucleus, and therefore its penetration effect or attraction towards the nucleus will be less. Moving on to the next property, electronegativity. What is electronegativity? Atomic electronegativity is the measure of atoms' ability to attract the shared pair of electrons in a chemical bond. Electronegativity is a relative scale developed by Linus Pauling, with fluorine being the most electronegative atom in the periodic table, assigned a value of 4, and cesium is the least electronegative element in the periodic table with a value of 0.79. Now electronegativity is a property of bonded atom in a molecule. So you can assign electronegativity values only to those atoms that are associated with other atoms by a chemical bond. So you cannot assign electronegativity values to isolated gaseous atoms. Let me explain the concept of electronegativity with respect to the hydrogen chloride molecule. In case of hydrogen chloride molecule, hydrogen and chlorine atoms are held together by covalent bond, and this is shown by a solid line joining the hydrogen and chlorine atom. A covalent bond is formed by mutual sharing of electrons between the atoms involved in bond formation. But in case of hydrogen chloride molecule, the electron pair is not equally shared, but rather it is unequally shared. And this is shown by an arrowhead pointing towards the chlorine atom. So what is the significance of this arrow? It represents or it shows that the shared pair of bonding valence electrons is pulled closer to the chlorine atom, because chlorine is more electronegative than hydrogen atom. So chlorine, it has a value of 3.15 on Linus Pauling scale, while hydrogen has electronegativity value of only 2.1. So electronegativity value of chlorine is more than hydrogen, and as a result, it pulls the shared pair of bonding valence electrons closer to itself. And as a result of this, the chlorine atom gains a partial negative charge, while the hydrogen atom gains a partial positive charge. And this is indicated by Greek symbol delta, meaning small. So chlorine has a partial negative charge, while hydrogen has a partial positive charge. And therefore, hydrogen chloride molecule has a positive and a negative end. Now the crossed end is the positive end and the arrow end is the negative end. Now the hydrogen chloride molecule is a polar molecule with a polar covalent bond. Now we have two questions. What are those? Number one, why chlorine is more electronegative than hydrogen? Number two, why chlorine attracts the shared pair of bonding valence electrons closer to itself? So let's find out the answer by examining the electron structure of hydrogen chloride molecule. Now chlorine has 17 positively charged protons in its nucleus, while hydrogen has only one proton in its nucleus. So the attraction of 17 positively charged protons of chlorine towards the shared pair of bonding valence electrons is greater than the attraction of the only proton towards the shared pair of bonding valence electrons. And as a result, the shared pair of valence electrons is pulled closer towards the chlorine atom. So chlorine atoms with 17 protons in its nucleus wins the tug of war due to Coulombic force of attraction towards the shared pair of bonding valence electrons, and hydrogen with only one proton is just a mute spectator to watch the shared pair of electron moving towards the chlorine atom. It is not that hydrogen atom has lost the electron, it is only unequally shared. It is moving closer to the chlorine atom away from the hydrogen atom, and therefore chlorine is more electronegative than hydrogen on a Linus Pauling scale, and it pulls the electrons, shared pair of bonding valence electrons, closer to itself because of the Coulombic force of attraction. Now electronegativity is a relative property on a relative Pauling scale of 0 to 4, and the relative Pauling scale is based on bond dissociation energy. That is to say, electronegativity can be calculated based on molecular properties like bond dissociation energy. So what is bond dissociation energy? It is the amount of energy required to break a bond. So 432 kilojoules per mole of energy is required to break the covalent bond, polar covalent bond in case of hydrogen chloride molecule. And Linus Pauling, he calculated or assigned the electronegativity values based on bond dissociation energy and some other atomic molecular properties. And why homoatomic molecules like hydrogen and chlorine are non-polar in nature? Because the pair of electron is mutually shared between the two hydrogen or chlorine atoms involved in bond formation. So the shared pair of electron is equally pulled on either sides and there's no dipole. There's no net dipole. Therefore, hydrogen and chlorine molecules, homoatomic molecules, are non-polar in nature. Now, what are the factors affecting electronegativity? Atomic radius. So as the size of the atom increases, electronegativity decreases. With increase in the size, the distance between the nucleus and the outermost valence electron, the shared pair of bonding valence electron, increases, and this decreases the attraction. So as the size increases, electronegativity decreases. And as the shielding increases, as the number of shells with core electrons increase, electronegativity decreases. Because the core electrons, the shells with the core electrons act as shields and they reduce the electrostatic force of attraction between the positively charged protons and the outermost valence electron. And thereby the electronegativity value decreases with increase in shielding. And therefore, electronegativity value in case of magnesium will be less as compared to that of beryllium. The next factor is nuclear charge. So nuclear charge is directly proportional to the electronegativity. So as the number of charges increase, the electrostatic force of attraction or the coulombic force towards the valence electrons will be more. And therefore, it will be having a more pull. As the number of nuclear protons, positively charged protons increase, it will be having the coulombic force will be more towards the shared pair of bonding valence electrons, and therefore the electronegativity value increases. And what about the electronic configuration? Now, for example, fluorine atom, it has 7 valence electrons in its outermost shell, and it wants to gain an additional electron in order to attain the stable electronic configuration. So in order to attain the stable electronic configuration, it gains an additional electron. That is the driving force. And same in case of fluorine atom. Fluorine atom has 7 valence electrons. It tends to gain additional electron in order to attain the stable electronic configuration to that of the nearest noble gas. So nearest noble gas is neon for fluorine and argon for fluorine. So this is the driving force to attain to attract the electron to complete the octet or to form a full octet. And that is why fluorine has a value of 4 as compared to that of fluorine with 3.2. And we'll see why fluorine is having a greater electronegativity value than fluorine very shortly. And moving on to electron affinity. What is electron affinity? Electron affinity is the energy change that occurs when atom in the gas phase accepts an electron to form a negative ion. And electron affinity of fluorine is minus 332.2 kilojoules per mole. So energy is released. So electron affinity, if it is exothermic, energy is released, and this is shown by a negative sign. So what is the significance of this negative sign? So negative sign indicates that energy is released during the reaction. And electron affinity is the measure of atom's ability to accept an additional electron to form a negative ion. So let me explain the electron affinity concept with respect to fluorine atom. Fluorine atom, as I already mentioned, has 7 valence electrons in its outermost shell, and it tends to gain or it is striving to gain an additional electron to complete its outermost valence shell. So fluorine has 9 protons in its nucleus, and because of the coulombic force of attraction, it tends to attract the incoming negatively charged electron. So fluorine accepts the electron, and in the process, the kinetic energy of the electron is converted into electric potential energy, and this energy cannot be stored, it has to be released or it has to be lost. So it is this energy which is being released. That is minus 332.2 kilojoules per mole is the amount of energy released in the process of the isolated gaseous fluorine atom accepting a electron, and it forms a negatively charged fluoride ion. Now electron affinity is a property of isolated gaseous atom. Now what are the factors affecting electron affinity? The same factors what we have discussed in case of electronegativity, the same factors are affecting the electron affinity. Now I'll be explaining these 4 factors in detail by considering the period 2 elements in the periodic table. Now electronegativity and electron affinity, they are two closely related terms. Though they are closely related terms, they have entirely different meaning. Now I'd like to highlight 4 contrasting features between electronegativity and electroaffinity. Now electronegativity is a property of a bonded atom in a molecule. For example, hydrogen chloride and hydrogen fluoride. While electron affinity is a property of an isolated atom, like for example fluorine and chlorine atom. Electronegativity is a relative property, so where you can compare the electronegativity values on a Linus-Pauling scale based on bond dissociation energies of molecules. That is based on molecular properties like bond dissociation energy, while electron affinity is a fixed property. So electronegativity cannot be calculated. It can be calculated but cannot be measured, while electron affinity can be measured. So electronegativity cannot be measured but it can be calculated, while electron affinity can be measured. So electronegativity has no units, while electron affinity can be measured in kilojoules per mole. Now as you move across the period from the left to right in the periodic table, you will find that both electronegativity and electron affinity increases, and we'll see why. So I'll be considering the period 2 elements in order to explain this. So lithium has 2 shells, beryllium has 2, boron has 2 shells, carbon has 2, nitrogen has 2, oxygen has 2, fluorine has 2 shells, and neon has 2 shells. Now what about the number of protons? Lithium has 3 protons in its nucleus, beryllium has 4 protons in its nucleus, boron has 5 protons, carbon has 6 protons, nitrogen has 7 protons, oxygen has 8 protons, fluorine has 9 protons, and neon has a total of 10 protons in its nucleus. Now what do you observe here? You observe that as you move from left to right in the periodic table, that is with reference to period 2 elements, you will find the number of protons increase. And as I already mentioned, as the nuclear charge increases, the effective nuclear charge increases. So what about the shells? So the number of shells remain constant. So it is 2 for all this 8 elements. So shielding is constant. So effective nuclear charge increases while shielding is constant as you move across a period from left to right in the periodic table. And what about the number of valence electrons? So lithium has 1 valence electron, beryllium has 2, boron has 3, carbon has 4, nitrogen has 7, oxygen has 8, oxygen has 6, fluorine has 7, and neon has total of 8 valence electrons. So neon is a noble gas with a stable electronic configuration. So atoms close to achieving a full octet will exhibit higher electronegativity and electron affinity. For example, halogens like fluorine. So now you know, so this is one of the factors, that is stable electronic configuration. So now you know why atoms close to achieving a full octet will exhibit higher electronegativity. Because it wants to gain additional electron in order to attain the, in order to achieve a full octet. So what about the electronegativity values? As you move across the period from left to right, the electronegativity values increases, and there is no electronegativity value for noble gas like neon. You cannot assign, or you cannot define electronegativity value for noble gases. Why is that? Because electronegativity, as I already told you, is a property of a bonded atom in a molecule. And therefore, electronegativity is a property that only occurs in atoms that are joined together by a covalent bond to another atom. So electronegativity and electron affinity tends to increase as an atom gets closer to achieving a filled valence shell. But so that is why the hydrogen fluoride molecule is polar in nature, where the fluorine atom, because of its greater electronegativity, it pulls the shared pair of bonding valence electrons closer to itself, making it a polar molecule. So as you can see, the fluorine is very close to the noble gas group or the zero group of elements. So its tendency will be more to attain the stable electronic configuration, and therefore electron negativity and electron affinity of fluorine atom will be more. And electron affinity, as per the general trend, it should increase across the period, but there are few exceptions with beryllium and nitrogen showing anomalous behavior. So here in the values you can see beryllium and boron is having a positive sign, showing that addition of electron will make the atoms unstable. So addition of electrons in case of beryllium and nitrogen will make them unstable, leading to a unstable electronic configuration, and therefore it is endothermic process in case of beryllium and nitrogen. So there are few exceptions in case of electron affinity as you move across a periodic table from left to right. Don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.